Hi Year 7, this is our first lesson for our new topic of indices. In this lesson we're going to look at index form. Now multiplication is repeated addition. So instead of writing 2 plus 2 plus 2 plus 2 plus 2, we can write 5 times 2, which is 10. Similarly, we write repeated multiplication in index form. So instead of writing 2 times 2 times 2 times 2 times 2, we can write 2 to the power of 5, where 2 is the base and 5 is the index. We also call an index an order, a power, or an exponent. And the plural of index is indices. This is how we read the following numbers. This is 7 squared and 7 cubed. But any higher powers, we will say 7 to the power of. So this one is 7 to the power of 6. So let's write these in index form. Our base number is 3, and altogether there are 6 of them. So this is 3 to the power of 6. How about this one? This is 7 cubed. Now, what about this one? Be careful here. The base numbers must be the same. So all we can do is write 2 squared multiplied by 5 cubed. We can also expand numbers that have been written in index form. So this would be 4 times 4 times 4 times 4 times 4 times 4. And 5 times 5 times 5 times 5. How about this one? I'm going to have 2 times 2 times 2 times 3 times 3 times 3 times 3 times 5. Now this question is asking us to find the actual value of 5 squared. And that means 5 times 5, which is 25. What about 2 cubed? This means 2 times 2 times 2. Now don't make the mistake of thinking that's 6, because that's 2 plus 2 plus 2. 2 times 2 is 4, times 2 is 8. What about 10 to the power of 4? That's 10 times 10 times 10 times 10, which is 10,000. Now I just want to pause for a second to think about powers of 10. Can you see a pattern here? 10 squared is 100, 10 cubed is 1,000, 10 to the power of 4 is 10,000, 10 to the power of 5 is 100,000, and 10 to the power of 6 is 1,000,000. There is a shortcut. The index tells us how many zeros there are. See, 3, 3 zeros, 4, 4 zeros, 5, 5 zeros. So 10 to the power of 7 would be a 1 followed by 7 zeros, or 10 million. Let's move on. Whole numbers that are squared are called perfect squares. And the first 5 perfect squares are 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared, or 1, 4, 9, 16, 25. And we touched on this briefly in our first topic, number theory. We said that squared numbers are called that because their dot patterns are the shape of squares. Whole numbers that are cubed are called perfect cubes. And the first 5 perfect cubes are 1 cubed, 2 cubed, 3 cubed, 4 cubed, and 5 cubed. If we work those out, they are 1, 8, 27, 64, and 125. And they actually form cubes. Now there are 3 buttons we can use on the calculator to work out the value of squares, cubes, and other powers. And they are the x squared button, the x cubed button, and the x to the power of anything button. Okay, pause the video and grab your calculator and try and work out these. Right, 19 squared. We're going to use this button here. The display will end up looking like this, and that is 361. 17 cubed, we're going to use this button. Gives us 4,913. And 5 to the power of 6, we're using this button here, and we end up with 15,625. And finally, order of operations. Remember that we looked at the order of operations in our first topic, and we can remember the acronym BODMAS. Now the O stands for orders, in other words, indices. So if we have a look at a question like this, we've got a multiplication to do and an order. So we're going to do this part first. So this is 4 times 9, which is 36. And this one here, we've got brackets and a power or an order. So we're going to do the brackets first. So that becomes 5 squared, which is 25. Okay, that brings us to the end of our first lesson. Our next lesson is on prime factors.